Question 30D. In an investigation, students used different numbers of identical small solar panels to power model cars. The cars were then tested and their speed measured in kilometers per hour. The results are summarized in the table. The equation of the least squares line of best fit, relating the speed and the number of solar panels, has been calculated to be y equals 2.125x plus 2.0375. Part 1. What would be the speed of a car powered by 5 solar panels based on this equation? So y is equal to 2.125. Now x represents the number of solar panels, and we need to substitute 5 for x. So we're going to multiply 2.125 by 5 plus 2.0375, and just calculating the speed, 2.125 multiplied by 5 plus 2.0375. So it's just a simple substitution, and we get 12.6625 kilometers per hour. Okay. Now it doesn't say it's around it, but we could round it to 2 decimal places, so I'm just going to leave it as it is. Part 2. Calculate the correlation coefficient R between the number of solar panels and the speed of a car. Now, this is where a formula is required, and I'm just given the formula down here. Okay, now this is in fact a formula given in an older formula sheet, so this question comes from an older syllabus. So this is the formula here. Gradient equals R multiplied by standard deviation of y scores over the standard deviation of x scores. Okay, so I've just written there that same formula here. So we know the gradient. Okay, the gradient of the formula is 2.125. So I'm just going to substitute in some of the values that we know, and we're going to solve for R. So the gradient is 2.125 is equal to correlation coefficient R multiplied by, now standard deviation of y scores. Okay, so we'll get that from the table. Okay, standard deviation of the y scores, which is the speed, so that's 2, over standard deviation of the x scores, and that's 0.8. Okay, now what we need to do is just rearrange this formula to get R. So 2.125, if we divide that by 2 over 0.8, okay, so it's just a simple rearrangement to make R the subject of the formula. So it's just basic algebra, really. Okay, 2.125, now we can just calculate or just evaluate the left-hand side, 2 over 0.8, and we get a correlation coefficient of 0.85. Okay, so therefore R is equal to 0.85. And how would you categorize this, the strength of this relationship and the direction? So this would be a strong relationship, a strong linear relationship, and because it's over 0.75, this would be a strong positive linear relationship.